If fractions are taught very well and very thoroughly, decimals are much easier for students because decimals are really just fractions in a way. They're representing parts of a whole. They're representing parts written in a different way that are connected to tens, hundreds, thousands, etc. There's a strong relationship between fractions and decimals. We need to make sure we don't make any assumptions when teaching decimals. First thing we need to talk about is the academic language. Deci. What does deci mean? We want students to think of as many words as they can that have deci in them. What is a decimal? We want them to understand that we're talking about tens here, that decimals are related to tens. We also want to make sure that we connect what we're talking about with decimals, which are parts of a whole, to things we've already learned about whole numbers. We have learned with whole numbers place value. We've talked about ones, tens, hundreds, the three members of the family. Then our next family, 1,000, 10,000, 100,000. Then our next family, 1 million, and so forth. One thing I like to teach my students is that the ones is like a mirror when we talk about place value. The ones represent one whole thing. And if we move this direction, we're making a lot more of those ones. We're grouping those. We're getting bigger and more of them. If we move this direction, we're taking a 1 and we're breaking it into pieces. And that's what this decimal shows us. This decimal separates for us the wholes from the parts of a whole. So when we're going this direction, we're getting more and more wholes. When we're going this direction, we're breaking one whole, just one, into smaller and smaller parts. So no matter how far we go this way, we're never going to get to 1. Even if we have 30 numbers on this side of the decimal, or 100 numbers, we're never going to get to one whole. So students can see this ones place like a mirror. On this side we have tens, hundreds, thousands. On this side we have tenths, hundredths, thousands. The two sides actually mirror and copy each other, except here we're making groups, and on the right side we're breaking that 1 into pieces, into 10 pieces, or 100 pieces, or 1,000 pieces. The relationship between the two makes learning place value much easier for students. As with all math concepts, we want students to be able to see decimals, and our place value blocks can help us again. If we use place value blocks to teach decimals, we need to be very intentional with students and tell them that we are now seeing them differently. When we look at our place value blocks, we're going to look at this as one whole. And we're going to look at this as 1/10 of that whole, because 10 of these will fit in our whole. So each one of these is 1/10. We have to tell our students that these now are 100th, because there are 100 of these in our whole. So we have 1 whole, 1/10, and 1/100th. We're taking our 1 whole and we're breaking it into 10 pieces or 100 pieces to get started. We can also use grid paper with students, and we can give them a 10 by 10 grid like this, which very much looks like our whole with place value base 10 blocks, and we can say, here is our whole. This is one whole. You will notice that there are lots of little pieces in it, and if we count up all these little pieces, we're going to find that there are 100 of them. We can also look at the strips in our drawing, and if we count up all of the strips, you're going to notice that there are 10 of them in our whole. So our whole square is 1 whole, each strip is 1/10, and each little tiny square is 1/100th. Once we're sure that students understand what decimals are and what the parts of decimals are, the fact that they're all tens, hundreds, thousands, etc., then we can start relating them to fractions. We can say decimals are just another way to show a part of something. So for example, if we look at this square and we think about fractions, which we've already worked with our students, if we look at our square and we look at this, we want to know what does 2/5 of that whole look like. So what we would have to do is we would have to break our whole into 5 equal pieces because fractions means equal pieces. So here we have fifths. 1, 2, 3, 4, 5. 2 of those fifths would mean this much. That would be 2/5. Now, if we were going to look at that as a decimal, we know that we have to write a decimal in terms of tenths or hundredths. So we could look at our answer here and we could say, how many strips do we have? We have 1, 2, 3, 4. And if each one of those strips is a tenth, that means we have 4 tenths. Tenths is also the first place in the place value after the decimal. So we can write 4 tenths like this, we can write 4 tenths like this, and we know that all 3 of these two fractions, and this decimal are the same amount. They all represent this piece. If we think about 3/4, we think 1, 2, 3, 4, 5. Let's divide this down the middle. And let's divide it again this way. 3/4, 1, 2, 3 out of 4 equal pieces. To call those pieces a decimal, we need to express it in a power of 10. That means we need to have it be in tens or in hundreds. So if we look at each little piece and if we were to count them all up, I think what we would find is that there are 25 little pieces here, and 25 more here, and 25 more here. So we would have 75 of those little pieces, and those little pieces are hundredths. So we would have 75 out of 100 pieces. If we write that as a decimal, we have our decimal point to show us that we're going to be writing on the right side, which means a part, and we have 75 hundredths. All 3 of these, the 2 fractions and the decimals, are representing exactly the same amount. But we're writing our decimal with a decimal point and using place value to write the 75 hundredths. When we ask students to start working with operations with decimals, it's very good to still allow them to use base 10 blocks so they can see what they are doing. One of the most important lessons that students need to learn when they're adding and subtracting, working with decimals, is that they can only add like things. We learned that when we were talking about fractions, but it's important in decimals as well. So for example, if we look at this number, that number means we have 2 tenths and 5 hundredths. 2 tenths and 5 hundredths. This number means we have 1 whole, because that 1 is to the left of the decimal point. There's our 1 whole. And we have 4 tenths. 1, 2, 3, 4. So that's what this number looks like. Our final number is 33 hundredths, or 3 tenths and 3 hundredths. So here are our 3 tenths, here are our 3 hundredths. And if we added all of these up now, if we go back and look at our problem as a total, what we want students to remember is that we can only add like things. So looking at the base 10 blocks, what do we have? We have 1 whole. We add our decimal point because everything else is just pieces. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. And we have 1, 2, 3, 4, 5, 6, 7, 8 hundredths. So we have 1 whole, 9 tenths, and 8 hundredths, or we could say 1 and 98 hundredths. When we do the problem here, we're doing the same thing. We can only add things that are the same. Sometimes when students add, they get their decimal points all out of alignment, and teachers will say, now remember, line up your decimal points. But lining up your decimal points is just telling them a rule. Students aren't really understanding why they're doing that. What we want them to understand is that by lining up their decimal points, then they're going to be adding things that are the same. These are hundredths. so we add those together. These are tenths, so we add those together. Our decimal point separates the whole and the part, and this number is our whole. We want them to know why it's so important to keep those things lined up, because we only add things that are the same. We want to do the same thing when students are subtracting. So if we look at this problem and we say to students, what does that problem mean? We have 2 whole and 6 tenths. 2 whole and 6 tenths. So these base 10 blocks show us 2 and 6 tenths. Now from that 2 and 6 tenths, we want to take away 1 and 2 tenths and 3 hundredths, or 23 hundredths. So what can we already do? Well, we have 2 wholes and we can take 1 away. If I take that 1 away, I'm left with 1 whole. From these 6 tenths, I need to take away 2 tenths. I can do that. If I take away my 2 tenths, I'm left with 4. But what I haven't done yet is I haven't taken away 3 hundredths. How am I going to do that? Well, what I might have to do is I might have to take one of these 10 strips and break it into 10 hundredths, 10 little blocks. So I'm going to take that away and I'm going to trade it for 10 of the smaller squares. So that 10 is now gone, and instead I have the 10 squares. From those 10, I can take away 3. 1, 2, 3. What am I left with? I'm left with 1, 2, 3 tenths, and I'm left with 1, 2, 3, 4, 5, 6, 7 hundredths. So my answer is 1 and 37 hundredths. We want students to understand, just as when they worked with whole numbers, that they only have to trade when they have to, and that if there's nothing here, we can't take 3 away from nothing. We have to make sure there are some things there for them to work with. So when they do this then mathematically, what they're doing is they're saying, I don't have any hundredths here, so I'm going to take one of those tenths. I'm going to break it into 10 100ths. Now I can subtract. 5 tenths take away 2 tenths is 3 tenths, and 2 wholes take away 1 whole is 1 whole. That's the kind of language we want students to use so they're able to explain their thinking. Base 10 blocks can also help us when students are learning to multiply decimals. So in this problem, we have 3 and 2 tenths. We have 3 wholes and we have 2 tenths. What is the problem asking us to do? It's asking us to take that 3 and 2 tenths 5 tenths times. That means we want 5 tenths, or half, of what we started with. So we need to look at everything we have and we need to take half of it. Well, if I look at these 2 and I take half of that, I can take 1 whole. If I look at this and take half of it, that would be half of the whole, which would be 5 tenths. And if I take half of this, that would be 1 more tenth, so I would have 6 tenths total. If I look at just the problem, when we teach procedures, we can tell students, let's just not think about those decimals at the beginning. Let's just multiply. 5 times 2 is 10, 5 times 3 is 15, and 1 is 16. But now I know that I need to think about a decimal point. So we want them to think logically. If I had 3 and a little bit more of something, and I'm going to take it 1/2 times, how much would I have? Well, probably about 1 1/2, right? So where can I put my decimal where my answer will be close to 1 1/2? If I put it there, I have 1 and 60 hundredths, or I can think of it as 1 and 6 tenths. So that seems right, and it matches my picture. Eventually, we can teach kids that mathematics does the work for us, that by adding up how many numbers are after the decimal, 1, 2, and making sure we have that many numbers after the decimal in our answer, we will have the right answer. But that's a procedure, that's a rule. We want them to make sure that they can always explain why. Learning the rule is good, it's efficient. But if we ask them, why do you think that works? We want them to be able to use logic and reason to explain why their answer makes sense. Base 10 blocks also help us when we're dividing with decimals. So in this problem, we have 2 and 8/10, 2 wholes and 8/10. We want to know how many 4/10 are there in our 2 and 8/10. Well, 4/10 looks like this, right? So we want to know how many of these are there in our 2 and 8/10. So we're looking for groups of 4/10. 1, 2, 3, 4, there's one group. 1, 2, 3, 4, second group. 2, 3, 4, 3 groups. 1, 2, 3, 4, 4 groups. 1, 2, 3, 4, 5 groups. 1, 2, 3, 4, 6 groups. 1, 2, 3, 4, 7. There are 7 groups of 4/10 in our 2 and 8/10. So our answer is just 7. When we get to the procedure, we often teach students to do something like this. We say, well, we'll move our decimal over there to get rid of it, and if we do it there, then we have to do it here. Our decimal is now here. We'll put the decimal straight up, and then we can just divide. How many 4s are there in 28? 7. There's our answer. But we want to make sure that students understand why that works. Why is it okay for them to do that? And how do they know that their answer makes sense? When they move the decimal point, what are they doing? They're taking it times 10. So if we take one thing times 10 and we take the other thing times 10, then we're keeping the relationship the same, and we can do that. Now we have numbers that are much easier to work with. Our decimal point goes straight up because we're separating our whole number from our parts, and we may have parts, we don't know yet. So when we divide, we find out if we have parts or not. In this particular problem, we did not. We have a whole number of 7. We want students to go back then and check their answer with logic. 4/10 is almost half. How many halves would there be in 2 and 8/10? Well, in 2 whole things, there would be 4 halves, 2 in each one. And we could probably at least get another half out of this one, right? So 5. So a really rough estimate would be 5, probably a little more. And if our answer is 7, that kind of makes sense. If our answer had been 70 or 7/10, that wouldn't have made sense. When we get to procedures with this kind of work, again, we need to make sure that if students are confused, they can back up. They can look back at the base 10 blocks to picture the math, to see what the problem means. So just reviewing the procedures quickly, what do we want students to be able to say? We want them to know that if they're adding, that nothing here is the same as a 0, that they're adding like things. So if they add, the decimal is separating the parts from the whole. We end up with 8 wholes, 7/10, 6/100, and 1/1000. If we're subtracting, nothing here is the same as a 0. If we have none of something, we can't take 6 away. So we're going to go over here to our tenths. We're going to take a tenth. We're going to break it into 10 100ths. 10 hundredths take away 6 is 4. Now we have 2 tenths, take away 7. We can't do that. So we'll go over to our wholes and we'll take 1 whole away. We'll break that whole into 10 tenths. We already have 2 tenths there, so now we have 12. 12 tenths, take away 7 tenths, is 5 tenths. Now we're adding our decimal to separate our wholes from our parts. We have 4 wholes, take away 2 wholes, which is 2. And what we have left is 2 wholes and 54 hundredths, or 2 wholes, 5 tenths, and 4 hundredths. When students are multiplying with procedures, we can ask them to estimate their answer first, if we want to, so that they're sure that their answer makes sense. Or we can tell them just multiply, and we'll worry about the decimals later. We'll figure that out after we get an answer. So if we multiply this problem, 5 times 1 is 5. 5 times 3 is 15. 5 times 2 is 10 plus 1 is 11. 5 times 3 is 15 plus 1 is 16. And then we look at our answer. If we have 3 wholes and then a little bit more, and we're taking it 1/2 times, 1/2 of our 3 wholes, what will our answer be about? Well, half of 3 is 1/2. So if we put our decimal here, our answer will be close to 1/2, and that's sensible and logical. Then if we look at our rules, our memorized rules for multiplying decimals, if we add up all the places here, 3, plus 1 more here, 4, and if we make sure in our answer there are 4 numbers after the decimal, 1, 2, 3, 4, that also works. So our answer probably is correct. When we're dividing decimals, we start with our whole and our parts, what we have, 5 and 28/100ths, and we're going to divide by 3/10. It's kind of hard to picture 3/10, how many 3/10 are in this, so to make it easier, we can just multiply this times 10, so instead of 3/10 we now would have 3. But if we multiply this times 10, then we also have to multiply this times 10, so our decimal is now here. Since we multiplied both of these by 10, our relationship has not changed. Now we can divide. How many 3's are there? We can do our regular division. How many 3's in 22? How many 3's in 18? And then we want to look again and see, does our answer make sense? Is it logical? This might be hard for students to envision, but it's good for them to try to think about it this way. How many 3/10 would there be in a whole? Well, at least 3, right? Because 3/10 would be 9/10, and that's close to a whole. So if we have almost 3 of these in every whole, and we have 5 wholes, that would mean our answer should be at least 15. And since our answer is 17 and 6/10, that makes sense. It's logical. When fractions are taught well, and decimals are related clearly to fractions, we want to make sure that students can work with both, that they don't forget one as they work on the other. So what we want them to be able to do is to think about 3/5. They've already done finding common denominators. They know that for a decimal we need to get that 5 to either a 10 or a 100. So we'll take it times 2/2, which gives us 6/10. 6/10 can be written like this. So this, all represent the same amount. This one, we really can't get that denominator to a 10 very easily, but we could get it to 100 by taking it times 25. So if we take the bottom number times 25 and the top number times 25, we get 75/100, or 75/100ths, which can be written as a decimal like this. And again, this, all different ways of writing the same amount. 1/8. This is where we get really tricky with kids. We can't get an 8 easily to a 10. We can't get it easily to 100. And this is where our procedures come in, where we actually look at what our symbols mean. What this means is 1 divided by 8. And if we use our division skills to figure out what this is, we will get to the point where we can calculate that that is 125 thousandths. This is a very difficult thing for kids to understand. And truthfully, this is a place where as a teacher, I have just taught the procedures. I've had them try to imagine, try to estimate, try to come close, but it's just very difficult. They need to understand that by dividing, we're actually changing a number into a base 10 number, and that can be very confusing. We also want to convert the other way. We want students to be able to tell us that this is 8/10, which can be written this way, and that 8/10 can be simplified, not reduced, but simplified to 4/5 by dividing both parts by 2. We want them to be able to tell us that this is 30/100ths, which if we divide by 10 is the same as 3/10, so that they can see that fractions and decimals are closely related and are both used to represent parts of a number. Whenever possible, we want to make sure that we bring in real-life examples of decimals. Decimals are used all over the place, and students can tell us many places where they see them. They might talk about batting averages. They might talk about measuring. Here in the pictures we see stopwatches or gasoline prices, which are so interesting because they use decimals and fractions together, or money. We need to make sure that students see that math is authentic, that math is real in the world and not just problems that they do in the classroom.